Good afternoon. Today I am going to present our paper, Provenance Navigator, towards more usable privacy and data management strategies for smart applications. Billions of people are using smart apps on their smart devices for browsing, chatting, emailing, entertainment, fitness, navigation, shopping, social networking, transportation, and many other activities. Some of the popular apps are Facebook, Instagram, Chrome, TikTok, LinkedIn, Twitter. And many of these apps are having over a billion active users worldwide. The big question is, privacy and data management strategies given by the providers for these smart apps are usable? To know the answer to the question, if privacy and data management strategies for the smart apps are usable, we conduct an online survey. The survey was published on various social media platforms like LinkedIn, Facebook, Twitter, and distributed to specialized groups working in the field of privacy. We received 50 responses that were completely anonymous. The survey results are divided into 4 sections that are demographic statistics, privacy policies awareness, users' response on existing smart apps privacy policies, and users' response to usability requirements. The survey contains 3 demographics questions related to the participants' gender, age group, and continent-wise location. Figure A exhibits gender-wise distribution having 52% male participants and 46% female participants. Figure B shows survey participants' age-wise distribution from 17 to 60 years that are most frequent users of smart apps. Figure C shows the continent-wise distribution of the survey participants. Privacy policies awareness responses. In Figure A, it can be observed that only 30% of the participants reads the privacy policies thoroughly before giving consent to the app providers, while 50% of them gives their consent without reading the privacy policies. Figure B shows that only 14% of survey participants fully comprehends of the privacy and data policies provided by popular app providers. In comparison to 56% of smart device users finds that they do not fully understand the privacy and data policies. Lastly, Figure C shows that a little over 1/3 of the participants are aware of common privacy laws and 1/3 are not aware of about them. Smart apps privacy policies. A majority of survey participants either disagree or is neutral. In response to the question whether the current privacy policies and data management mechanisms provided by popular apps are not usable, approximately 95% of the survey participants indicated that the lengthy privacy policies are one of the main demotivating factors to read and understand the policies. 80% of the survey participants think that multi-level privacy settings are too complex to understand. Participants' response for usability requirements. Figure indicates the participants' response on usability improvements on current privacy policies provided by smart apps providers. Approximately 85% of participants finds that short videos or pictures to explain privacy policies would be more intuitive. 50% of participants prefer that voice commands to enable or disable privacy settings will be easier in contrast to the existing interfaces. Participants believes that permission for any type of data collection must be kept disabled by default, and data collection process can be subscription-based. 70% of the participants agree that app providers should integrate mechanisms that will be able to automatically hide users' public content in case of no activity for a certain period of time, help users to make their profile available region-wise or country-wise, monitor inappropriate comments, photos, or videos proactively, irrespective of users' review setting, to rule out any harassment, trolling, or untoward incidents. App providers can include a mechanism that can generate a comprehensive report for how users' data are being used by them. Based on our study of privacy management mechanisms provided by popular app providers like Facebook, Google, and Microsoft, and the response that we received for the survey that we conducted, it can be inferred lengthy privacy policies hinder a thorough reading, which most users skip. Multi-level privacy settings add complexity as well as reduce usability. Only a few users change the privacy settings to configure it as per their requirements. Most of the users do not care to adjust the default privacy settings and prone to higher chances of privacy violation and data abuse. Social networking apps such as Facebook, LinkedIn, Instagram can easily be a target of data scraping. Smart apps run a large number of background services to communicate with their servers, continuously recording users' data. That motivated us to propose a mechanism that can tell end users how their has been used and they can monitor it easily. We propose a conceptual model of Provenance Navigator that can provide transparency in data collection and usage to avoid consumers' data overuse, misuse, or abuse in smart apps. It can help users to navigate the origin of and transformations applied to their collected data for better users' rights compliance and legal requirements coordination. It can be seamlessly integrated into smart apps. As shown in the slide, Provenance Navigator uses a client-server architecture. The server can be cloud-based, that interacts with the data collection and management module to pull users' data and stores the data in the form of data entities. Each data entry can link their agents, data usage and activities performed on the user's data. Provenance Navigator client consists of Provenance Navigator Visualizer, data collection and management, and local database modules. Directed acyclic graph generator fetches the information from the DCM module to dynamically construct provenance graphs that can be stored locally in the database. Provenance Navigator (PN) Visualizer can enable users to audit their data collection and usage by the app providers by querying to the database. Audits can reveal the state of data collected, the agents accessing the data, and the activities in which the data is used. In this slide, let's understand a typical provenance graph creation process. DAG generator fetches information from the DCM module to construct a provenance graph. By creating a new node for each data entity that a smart app is collecting, let's assume our data entry with size n that are used by M agents. If any agent used a data entity, an edge is established between them. Similarly, a new node AC can be created for each new activity performed by the agent. And a new edge can be defined between the agent and their activities to link them. This information can be easily fetched by the app users and they can know how their data has been used. Some recommendations to smart apps providers based on our survey for data collection and privacy management mechanisms can be: long and lengthy privacy policy texts can be replaced with short videos or pictures to add intuitiveness. Voice commands can be introduced for easy interaction to deal with privacy settings. Multi-level privacy settings introduce complexity that can be simplified to enhance usability. Opt-out options can be kept enabled by default. Users can opt in for a particular data tracking or selective services as per their preferences or requirements. The data collection process can be subscription-based. This will give flexibility to users to subscribe to the services for a desired amount of time. Further continuing the recommendations, data traceability mechanisms can be provided to users to link between the data collection permissions given by them and the usage purpose. Any inappropriate comments, photos, or videos can be monitored proactively, irrespective of users' review setting to rule out any harassment, trolling, or untoward incidents. Controls can be introduced for users to make their profile available region-wise or country-wise. Controls can be provided to users to generate a comprehensive report about how their data is being used by app providers over a period that they can select. The automatic hide feature can be introduced for users to hide their public content. Users can set the no activity period to enable this feature. With this, I conclude my presentation. Thanks to organizers for conducting this event, and would extend our thanks to anonymous reviewers for their valuable feedback.